Okay, tracking forward in 3, 2, and 1. I have Lauren's eyes tracking forward. I have Hermia's eyes tracking forward. I have Rakaya's eyes tracking forward. Scholars, last night I was doing 3 different equations, and somehow when I was doing these equations, I was coming up with the same product or the same answer. So the first equation that I wrote was 8 times 7, and 8 times 7 is 56. Do you agree? Do you agree?
Yes.
Okay. The next equation that I did was, you're still tracking forward, I did 8 times 4, and then I did 8 times 3, but I still got 56. So I did 8 times 4 and got 32, and then I did 8 times 3 and I got 24, and then when I added those products together, I got 36, or 56. Then the next time, I did an equation. This was my last equation that I did. I did 8 times 1 plus 8 times 6. And I added those products together, and I still got 56. Scholars, these are the 3 equations that I did last time. And I'm just like kind of a little bit confused because I'm like, wow, like all 3 of these equations are different equations, but I still got the same product or the same total. So, in my head, there's a couple questions I'm asking you. So right now you're thinking of the answer in your head, and then when I say go, you're going to turn to your table partner, and you're going to talk to each other about it. But I haven't said go yet, so I'm waiting for all eyes still. I'm waiting on 1 in orange. Your pencils are still down. Thank you. The question that I have for you right now is, what is the same about these equations and what is different about these equations? So you're actually answering that in your head right now. What is the same? You don't need to raise your hand because you're answering it in your head. And what is different? Now when I say go, you're going to turn and talk to your table partner in a whisper level voice. Go. Clap once, twice, 3 times. I need all eyes in 3, 2, and 1. I'm waiting on 1 in red. I have orange. Green row looks good. The table is ready. Thank you. Give a class point. Now we're going to share out some of our answers. What is the same about all 3 of these equations? What is the same? You raise a silent college bound hand, whether it's the morning or the afternoon. Mahogany? They all have an 8. Taylor also said they all have an 8, and so did Rakaya in their group. What else is the same? Jacob? The total is the same. The total is 56 in every single one. What is different in these equations? Jasil? Jasil is speaking. You're tracking Jasil. Nobody else is speaking. It is now different numbers. So she's saying that I broke the 7 up into different numbers. What different numbers did the 7 get broken up into? Let's talk about that since she already named that. That's really good. What numbers did she break up, or what numbers from 7 was broken up? Turn to your partner and tell your partner. Clap 1, Green row looks good, orange row looks good. I'm waiting on one table. Kimura, check, hands down. Okay. What number, what two numbers did they break up the 7 into in the second equation? Because that's what you guys were talking about before I went ahead and pulled you back to me. What were you telling your table partner? Jacob? Give me Jacob. He's not the first grade.
The numbers that change were 4, 3, 1.
Okay, so you're saying that 7 was broken up into 4 and 3 in this equation, and then 7 was broken up into 1 and 6 in this equation. Okay, okay. So essentially, all of the equations are equivalent. Are all the equations equivalent, or are all the equations equal? Do you agree or disagree? Are all the equations equivalent, or are all the equations equal? Do you agree, or do you disagree? Do you agree? Are some people unsure? Okay, put your hands down in 3, 2, and 1. Track me. All of the equations are actually equal. They are all equal. And the reason why they're equal, because a lot of people agreed and there were a few unsure, so let's talk about it for a minute. The reason why they're equal is because 8 times 7 is 56, right? Then they took 7 and they broke it up into 2 equal parts. Okay, meaning like they took a 7 and they broke it up that if you were to add them together, you add them together and you would get 7. So like 4 plus 3 added together is 7. So essentially you're actually really doing 8 times 7. Because you're doing 8 times 4, which is an equal part, and 8 times 3, which is an equal part. Okay? So you could actually take a common factor, a factor that you do not change at all. You can take a common factor and you can multiply it by 2 equal parts. What is the common factor in the second problem? What is the factor that they have in common? Taylor. 8. 8 is the common factor that is multiplied by 2 equal parts. What are the 2 equal parts that are being multiplied by that 8? Kaylee? Right. In this problem, what is the common factor? Amira? The factor that was multiplied by both equal parts. 8. And what is the 2 equal parts that they took and broke up from 7? London? 6 and 1. Good job. Now we're going to go into the teacher model, okay? So we're going to continue to talk about the distributive property, and the distributive property states that you can take a common factor like 8 and you can multiply it by 2 equal parts like 4 and 3, and if you take those products and you add them together, you will get the same total as if you were to just do 8 times 7. Mathematicians use this property to make it easier to multiply. So basically you're multiplying by smaller numbers instead of multiplying by a larger number. I need everybody to turn their attention to their paper in 3, 2, and 1. And I'm going to make a few changes because I have a feeling that if I don't make these changes, we're going to have some issues as far as making deals tomorrow. So Rakai, I need you to find your seat over here for me, please. And you can be Amira's partner now that Andrew's kind of stepped out. So take your paper over there. Thank you for doing that silently. And Cyrus, I need you to turn your chair all the way in. All the way in. Thank you. So now we're in the teacher model 1. We're going to go ahead and read it. It says, use the distributive property to find the product of 9 times 8. We're going to split the 9 today. We're going to split the 9 into 5 plus 4. Why did I split the 9 into 5 plus 4? Raise a college-bound hand if you know why I split the 9, why 9 is the same thing as 5 plus 4. 3 people know. Almost the whole class knows. Taylor, why can I do that? Because 5 plus 4 is what? It equals 9. Now pay close attention. we're going to distribute the common factor of 8. We have 8, and we're going to multiply it by 5 plus 4. 5 plus 4 are the equal parts that we are multiplying the common factor by. Lavelle's got it down, so does Shamira. Jaceel has it down. We're going to distribute the 8, and we're going to multiply it by each equal part. We now have 8 times 5 plus 8 times 4. You can give a whole class point for pencils moving and working silently. We are now going to find the products of each equal part. Your pencil is moving right now. 8 times 5 is, Ryan, 40. Plus 8 times 4 is Kaylee. Now we're going to add each product together to get a final total. 40 plus 32. 2 plus 0 is 2, and 4 plus 3 is, Kamore? Now if we were to roll our 9s or roll our 8s 9 times or roll our 9s 8 times and do 9 times 8, what would we get? Roll it in your head. What is 9 times 8? Ryan? 72. Do they have the same total, Krista? Can somebody tell me why it's the same? Why do they have the same exact total? Like, why are they the exact same? Taylor? Why are they equal though? You're right, they are equal. Can someone explain why they're equal? Jaceel? You're tracking Jaceel and you're listening to her. All we did was split the 9 into 2 equal parts. So does it still equal 9? Yeah. 5 plus 4 equals 9. You told me that, right? So they're equal because all we did was take a common factor and we multiplied it by equal parts of another number. So like we're still doing 8 times 9. You just took the 9 and you broke it up into smaller pieces, and then when you multiplied it by the same number, you got the same total. So you can actually take a common factor and you can multiply it by equal parts and add those products together and still get the same total. It's just like when we were working with the arrays. All we did was break up the 9 into a smaller array, right? And then we added both of those arrays together. Now look at this problem down below. I want you to do this on your own. What other ways can you decompose 9? So if you were to take 9, we decompose it into 5 and 4. What other ways could you decompose 9? Write it on your paper. Yep, write it on your paper. What other ways, you're silently writing it on your paper, what other ways can you decompose 9? You're going to have a second to talk to your partner in a minute. You're thinking about what other numbers, if you were to add them together, if you decompose 9, besides 5 and 4. We've already used 5 and 4, so what other ways could we make 9? You're trying to make 9. If you can hear my voice, clap once, twice, 3 times. Your pencils are down in 3. Your pencils are down in 2. Your pencils are down in 1.